session of refrigeration and air conditioning. Now in this lecture we will be discussing the functions of the expansion device used in the vapor compression refrigeration system and why they are important from the cooling point of view. Now as far as location of expansion device is concerned, we know that expansion device are generally installed between the condenser and the evaporator, as you can see over here. So the circuit, once I am again repeating the direction of the movement of the working fluid in the vapor compression refrigeration system. So let us start again with the evaporator. So from the evaporator the refrigerant moves first into the compressor and then it moves into condenser where the phase change takes place, and vapor refrigerant is converted into liquid refrigerant, and then further it passes through the expansion device where the throttling of the refrigerant takes place, and then after the expansion device the refrigerant in low temperature and low pressure condition again enter into the evaporator. Okay. Now in this evaporator the absorption of the heat will take place from the product to be cooled, and hence this complete cycle will be repeated again and again. So these expansion devices play a very important role in refrigeration that we have discussed number of times in previous units. So let us first understand what are the functions of the expansion device. Now the first and foremost function of the expansion device is to reduce the pressure of the refrigerant which is at high pressure condition in condenser to evaporator pressure, which is the pressure in the evaporator. So the refrigerant in high pressure and high temperature condition from the condenser is converted into low temperature and low pressure liquid plus vapor mixture in the evaporator. And the second function of the expansion device is to control the amount of refrigerant passing through the evaporator according to the load on the evaporator or on the evaporation rate, what we can say in the evaporator. Now there are different types of the expansion device used in different applications. So we have number of expansion device as you can see in the slide. So first of all we have the first one, the simplest of the device is capillary tube, and after that then we have hand expansion valve which is nothing but operated by the hand, then automatic expansion valve which is nothing but a constant pressure type of the valve, thermostatic expansion valve, this is also called as constant superheat valve, and then the two float valves, one is low side float valve, another one is high side float valve. Okay, so whether the float valve is used on the side of the evaporator, then it will be called as the low side float valve, or whether the float valve is used on the condenser side, then it will be called as the high side kind of the float valve. Now this is the slide which shows the expansion device, the simplest of the expansion device, that is the capillary tube, and you have seen this capillary tube in your RAC lab also. Now here as you can see, the upper one shows the schematic diagram of the capillary tube, and the below one as you can see the pic revealing the capillary tube. Now as you can see from the upper one, the capillary tube is the one which is having a very small diameter and the length is comparatively large, and it is coiled in the, it is in the generally in the form of the coil. Okay, so here also as you can see here, this is the capillary tube, okay, which is connected in between the condenser and as you can see the evaporator. Okay, and as shown here, the liquid refrigerant is coming from the condenser. So here as you can see, the liquid refrigerant is coming from the condenser. Okay, then it passes through the strainer. As you can see here, the strainer where all the foreign particles or dust or dirt, whatever may be there, is removed, and then it passes into the capillary tube. So here as you can see, the refrigerant is coming from the condenser, passes through the strainer, and then it goes into the capillary. So here as you can see, capillary is a small diameter tube, okay, very narrow, and diameter is around 0.5 to 0.3 mm, and the length ranges from 1 meter to 6 meters. Okay, and as you can see here, now the refrigerant passes into the evaporator. Okay, so due to the reduction in the area of the flow of the passage, so the pressure drop will take place, first due to friction, and second, you know that as the area reduces, the pressure also reduces, which consequently leads to the flashing of the liquid refrigerant into vapor. And these capillary tubes, you know, these are found in number of applications, for example in domestic refrigerator and window air conditioners also. Now this pic illustrates the hand expansion valve. These hand expansion valves, as you can see here, we have a hand wheel which is provided at the top, which is connected by means of valve stem to the valve, and finally the valve rests on the valve seat as shown here. Okay, so here as you can see, we have a needle valve and it rests on the valve seat, and liquid refrigerant is coming from the left hand side as you can see over here. Okay, so when the liquid refrigerant enters from the left hand side, according to the opening, okay, according to the opening provided by the valve, the refrigerant will be allowed to pass through the valve, and due to this small opening, as you can see, the pressure drop from condenser pressure, that is PC, to evaporator pressure PE will take place. Okay students, now the disadvantage of this one is that operator is required at every time for operating these kinds of hand expansion kind of the valve. Okay, but advantage is that they are easy to operate and simple in construction. Okay, now student, this slide is of automatic expansion valve, and this type of valve is also called as the constant pressure valve because it maintains the constant pressure on the evaporator. Okay, so this is how actually the automatic expansion valve looks like. Okay, and on the left hand side, as you can see, it has the adjusting screw which is below this blue colored cap, and to this adjusting screw a spring is attached, right, and the spring, at the end of the spring usually you have a diaphragm. Okay, so there will be a force acting due to the springs on the top side. Okay, and on the bottom, as you can see here, below the diaphragm, this is attached with by means of the valve stem to the valve, and this shaded portion is nothing but the valve seat. Okay, and liquid refrigerant usually comes from the left hand side, from this side as you can see. and here the strainer is provided. As discussed in the previous slide, the function of the strainer is to remove the foreign particles or any other dust dirt if there in the refrigerant, and then refrigerant passes from this side through this valve opening, and then it finally is discharged to the liquid. Refrigerant is discharged to the evaporator. So we have one force which is acting from the top side due to the spring pressure, and one is atmospheric pressure. I will describe it in the next slide. And then we have another force which is acting from below, which is nothing but the evaporator pressure. Now depending upon the opening between the wall seat here, the pressure drop from condenser pressure to evaporator pressure will take place. Okay. So let me now explain it with the help of the force diagram. Now here, as you can see, we have a same arrangement as I have shown in the previous slide. Okay. So as you can see here, at the top part again you have a adjusting screw. Okay, and with the help of this screw, the pressure on the spring or force on the spring can be adjusted, and this force on the spring is represented by Fs, as you can see over here. Okay, and the spring, as I told you in the previous slide, is adjusted or attached with the diaphragm. Okay, and F0, which is shown over here, is nothing but the force due to atmospheric pressure which is acting on the diaphragm. Okay, and on the other side of the diaphragm, that is on the downside of the diagram, we have the valve stand. Okay, which is connected to the valve, and this valve is resting on the valve seat, as you can see here, and to the valve another spring which is called as the follow-up spring is also attached. Okay, so the four forces, I repeat, which are acting on the diaphragm are: first one is due to evaporator pressure, Fe; second one is the force due to follow-up spring, FFS; third one is the force due to spring adjustment spring or adjustable spring, Fs; and the fourth one, F0, is due to the atmospheric pressure. Okay, and in this diagram also, as you can see, the refrigerants come from the left hand side, and then according to the opening provided at the valve, the refrigerant will be undergoing the pressure drop, and then it will pass to the evaporator. So in this type of the valve, under equilibrium, the force acting upward, the sum of the force which are acting towards the upward direction, that is Fe plus Fs, will be equal to the force which are acting in the downward direction, that is the sum of the force which are acting in the downward direction. So Fe plus Fs will be equal to F0 plus Fs. Okay, now if the load on the evaporator increases, then what happens? Now if the load on the evaporator increases, when I talk about load, that means the cooling requirement increase, then the evaporator pressure PE will increase. So here, as you can see, if the evaporator pressure increase, the PE will increase, which in turn will increase the Fe, and let us assume that this FFS, that is the follow-up spring, is constant. Okay, so then Fe will be more than the force due to spring which is acting from the top, and hence, as you can see, the valve will be moving in the upward direction, and the flow of the refrigerant to the evaporator will decrease, and reverse will happen in case the evaporator load decrease, that is the cooling requirement decrease. So if the cooling requirement decrease, as you can see here, the force Fe will be less. So force, if Fe will be less and Fs will be greater, then the valve will be moving in the downward direction, and as the valve moves in the downward direction, more refrigerant will be allowed to pass through this valve, and it flows to the evaporator. So that's why this is called